Now some logical operators, symbols and the meaning. Not, that is the exclamation sign, stands for logical not. And stands for logical and, it's an and operator. The pipe symbol, that is the standing straight line, stands for the or operator. Less than, we anyone know what less than means. Less than equal to is that it means it's less than or equal to. Similarly, greater than equal to will do a check whether the left hand side is actually equal to the right hand side of this operator. Not equal to does a check whether it's equal to what is on the right hand side. So if you have a 4 is not equal to 5, it is going to basically check whether these two are similar. If it is not similar, it will return a true, because that is what you intend to check over there. And if it is 4, if you are passing 4 not equal to 4, it will come as false. Why? Because when you are saying not equal to, actually they are true, right? So you are giving an opposite condition, so it will return your false. The double and sign is and with an if, and the double pipe is an or with an if, right? That's how you will have to see it. But from the notion of vectors, it also talks something about vector recycling. The double pipe stands for an or with an if. Now again the notion goes similar to the double and operator. So if a double and basically means that you don't want the vectors to recycle, and a single and means that you want the vectors to recycle in case they are not of equal size. So when you say a vector A and a vector B and you try to just do an operation, if one of the vector has 2 elements and the other has 5, if you use a single and, it will not do the vector, it will do the vector recycling. If you do a double, it will not do the vector recycling. That is what is the meaning. And XOR XY stands for exclusive OR, right? So basically an exclusive OR comes into picture when a statement will be marked as true only if one of them is true, right? So if both of them are coming true, it will be marked as a false. If both of them are false, anyway it's a false statement. And each true statement will check as to whatever procedure you have passed in that. So you have done a complicated formula inside that, it will just check whether it is coming true or not. Now let's come to some sequence generation. Now we have already done this with the form of 1 to 5 sequence and 5 to 10, just that we will be seeing it from the perspective of a sequence generation. Now if it's a regularly spaced sequence, that means they are equidistant, right? We can use something like a sequence operator, and we can say 1:10 and it will create a sequence from 1 to 10. But ideally you can say that 1:10 also does the same job, right? But there is a difference. Now this function lets you decide, contrary to the previous sequence wherein you did not use a function but just said 1 to 10, which does not let you decide what is the gap which you can keep between these, right? It's assumed by default that that's supposed to be 1. When you're using a sequence function, it gives you the flexibility to specify how do you want to separate the sequence. So if I say in the previous line, sequence 1 to 10, if I say comma and I say 2, so what it will do is it will first give 1, 3, 5, 7, 9 and so it will separate it by 2. That's what is the meaning, right? So in this case, where in sequence 0, 5 says that the number should start at 5, should end at 5, and the amount or the magnitude by which the increment should happen should be 0.5. So the sequence is 0.0, 0.5, 1.0, 1.5, 2.0, 2.5 and so on. Similarly, you can do a reverse sequence by saying sequence 5, 0, minus 0.5, and it does the reverse. So we are through with the sequence generating part. Now we'll jump into the next part, generating repeated sequence. So the rep, which stands for replicate, it's a replicate function. So basically you're trying to repeat something. So X allocation sign rep 6, 4, right? So you're asking the rep function to basically repeat 6 4 times, right? So that's how you will see this. So if you say rep concatenation function 11, 12, 13, 3, so it will repeat the sequence 11, 12, 13 3 times. So that's how it is coming, 11, 12, 13, 11, 12, 13, 11, 13. If you say rep 1, 2 3 times, it will do 1, 2, 1, 2, 1, 2, 1, 2, 1. That's how we'll see it. If instead of just passing the second parameter as a value, you say each equal to 2, it tells the algorithm that repeat each element 2 times and then create the next one. So that's what we see. So rep C 11, 12, 13, each is equal to 2 tells the rep function that you want each element of the vector, that is 11, 12, 13, to be repeated twice and that's how it becomes 11, 11, 12, 12, 13, 13. Now we come to sorting, ranking and ordering, that aspect of handling data. So say for example we want to sort some data. So what we can do is we can first create a vector, say sales, allocation sign C, 100, 50, 75, 150. All of them are not ordered in a sequence. Now if you want to just rank them, you can say rank, allocation sign rank, and the same variable or object. R is one such language wherein you can use the same object for self-referencing also. So that means you can write sales again back to the sales object, but that's dangerous for now. You should only do that when you have good hands-on experience with managing objects in R. So when you say rank, allocation, rank, sale, that where it get ranked, then you are saying sorted, right? If you say sorted, that's the object name you're creating, and you're saying allocation sign sort, sales, it will sort it in increasing order, right? And then when you say order, it will just put it basis the order. So if you want to see this, when we can just merge it back to a data frame. So you will say VIEW, an object you're creating in a not in a vector form, but all of these rank, sorted and ordered are basically vectors. Now I'm going to write this back into a new object, but you want it in a data frame form. Or be a little bit what I can see over here, the D is with a D capital. It won't get executed because this function won't be found. You have to write D with a cap, not with a capital D, but a D with a small letter. Data.frame should be in small caps, and then you will pass the object sales, right? So you're saying sales, and obviously you have to be very careful with handling the alphabet. So sales which you have created initially is sales with a small s, and what you're passing over here is a capital S, and it will throw an error. So you'll have to make sure that this is sales with a small s and rank with a small one, and all of that goes in the same order. All of them has to be in small caps, otherwise it will say object not found. And then you will put that over here, and this is how your table will look. The sales is the basic number in the unsorted form. Rank is where you have given some ranks to the data, right? And then the sort, wherein it is created in an small to large number sequence, and then there is the ordered category. Now we come to filtering vectors. So filtering with the subset function. So you can filter with subset. You can actually use a filter as there is a separate function filter also, and then you have direct handling of the vector also. Now we'll go for the subset function. So x allocation C 6, 1 sequence 3, NA, 12. So we are just basically preparing a vector. So this is the vector element 6, 1, 2, 3, NA, 12. Now you're saying x box bracket x greater than 5. So you're basically doing a subsetting over here. You're telling give me all those numbers which are greater than 5, and you wrap that, and outside that you say x. So what is happening internally is it's checking true or false whether that vector element is greater than or less than 5. So the first element 6 is obviously greater than 5, so it returns true. The second one returns false, the third one returns false, the fourth one returns false. Now for an NA, which is a not applicable, it is not getting trapped, so that will also be returned. So that is why we say that you need to handle missing values. And then the 12 is also returned as true. And for all those wherein the logical operator comes as true, when you wrap that and extract that, so x box bracket, so you have all these true false inside there. So for wherever there is a true, it will return you that value. So obviously you will get 6 NA 12. So subset function handles NA, whereas the basic operator wherein you mention x greater than 5 will not operate. This is the advantage of using a dedicated function. So when you say subset x, x greater than 5, it will return only those values which are numerically greater than 5, which was not handled by the previous method of subsetting. The selection function, which this also comes in handy when you want to do something with the position within a vector, right? So if you say z, you're creating a vector z allocation sign z allocation C, that is concatenate 6, 5, -3, 7, and this is the vector you have created. And when you say which z multiplied by z greater than 9, so basically it is going to do a multiplication of the vector and just trying to check whether it's greater than 9. So which are the vector, so it's basically giving you the location, not the values, because you're asking for the locations. So the first element 6 multiplied by 636 is less than 9 or greater than 9. It's greater than 9, so it's a true. 5 by 525 is greater than 9, that is 2. The second location is also returning you true. Minus 3 into minus 3 is 9, which is actually equal to 9, so it is false, so that's not the location. And the fourth location 49 is greater than 9, so that's a true. So it says that the first, second and the fourth location actually follows this rule. That's how you can see this. However, the expression z multiplied by z greater than 8 will be a bit different. So it is saying true, true, false, true. That's how we'll have to evaluate, right? R also includes a vectorized version, the if-else function. The form is if-else bracket b comma u comma v, where b is a Boolean vector and u and v are vectors. The return value is itself a vector. Element I is ui if bi is true. For example, if you create a vector x allocation sign 1:10 and you say if else x, right, you use the % sign 3 is equal to 0, so you're basically checking with the mod operator, right? And if it is actually coming out to be 0, then you are flagging it with a y, or else you are flagging it with an n, right? And this if else statement is exclusively used for most of your operations, right? And but the point is, if you use an if else, whatever is going to be created will always be a vector. So when you're working with data frames and if you're using an if else, you have to make sure that if you are getting something as a vector, when you want to purge it back, you have to make sure that it is going back as a data frame. Similarly, you have nested if else, right? So h is a vector, concatenation function, a, f, f, m, 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 f, all separated by commas. The commas are compulsory, right? And that's where you get this vector created. If you use an if else, you can check whether h is equal to m, so you're basically doing a cross check, comma 1, if else g double equal to f, comma 2, comma 3. So the first parameter is for true. The nested parameter is that if something goes wrong, if this is not applicable, what else you want to do. That's what is coming up in this. Now in R, typically you would be working most of the time with characters also, right? So you can use a allocation dash, right, allocation sign and a hello. So the hello string gets attached to a. Similarly, you can say b allocation sign 55. Now over here 55 is not a number. Reason being that you have given it double quotes, which tells R that basically you have to start treating this number as a character. So R will infer it as a character, and if you want to do some functions like summation and all those things, it won't work, right? So whenever you have anything with a double quotes in a vector form, it will always be taken as a character, right? So that is why when you use an as dot numeric a, right, it will say not applicable, right? It's a warning message. One of the initial confusing things about character string is the distinction between the length of a character object, a vector, and the number of characters in the string. So these are two different things which are quite confusing, right? So for example, you are creating a vector sports wherein you are saying allocation sign, concatenation, cricket, football, hockey, basketball, right? Now here, what is the length and what is the number of characters in the string are two different things, right? So we'll make that clear. So when you say length sports, so it gives you 4, right? So it's the it's basically the count. And now if you say n char, that is number of character in sports, so it will typically extract the number of characters in each of those words. So the first one will have 7, the second one will have 8, the next one 6, and the last one is having 10 individual characters. When first defined, character strings are not factors, right? So class sports, so you can check the form of the data with something like a class or structure, right? That is where you will get these things. So when you say class sports, it will say that this is a character, which ideally means that this is a character vector, right? Each dot factor of sports is a question whether it is a factor or not a factor, and it returns you that it is false. That means it's not a factor. Most of the time when you're working with algorithms, and specifically when they are class variables, categorical variables, you will have to convert that variable into a factor variable. So you might use something like an as dot factor to basically convert that. But the first thing is you will check whether it's a factor. It's a factor in itself. For that, is dot factor will help you, right? Now you're going to create a data frame. Now this is your movement from a vector to a data frame, right? So if you say df, which is basically an acronym you're using as an object for data frame, and allocation sign data dot frame and sports, now the same thing will get converted into a data frame. And then if you check is dot factor, right, and the column, now if you want to reference, is with the reference dollar sign and sports, that is the column over there. Now it will say true. Why? Because when you're doing it in data frame, it gets automatically converted into a factor if it's a character. There are inbuilt vectors in R that contain the 26 letters of the alphabet. So these are inbuilt, you don't need to create them. So if you just type letters small, you will get A to Z all in small letters, and if you type letters in capital and just press enter, it will say A to Z in capital, right? This is just for practice, right? So you can use these vectors for practice. To discover which number in the alphabet the letter K is, use the which form, right? So we'll be using which, and you say letters, that is small, which has A to Z in small, and then you say letters double equal to K with a double quote. That means you're basically checking which position has the letter K, right? So it returns you true false. So in the first one it will return false, and in the respective element, so I can see that on 11th it will return you a true, and when you say which, it will actually give you the location, that is the 11th location. To suppress the quotes that appear around character strings, so if you want to suppress, right, if you don't want to see the double quotes in printed form, you can say no quote letters and it will just suppress the double quotes. That is one function, no quote. To amalgamate or just to concatenate strings into a vector of character information, you can use C, A, comma, B. We have used this previously, right? So that's where you are just pushing both of them together. So A is a character vector which has hello, B is a character vector which has number 55 saved as a character. So when you say concatenate, both of them are combined together. Using modulo to know all the matches, right? So you can use this % sign to basically do comparisons, right? So if you're creating the same vector, football, cricket, basketball, baseball, again separated by a comma, and then you're creating a new vector called popular sports, wherein you're keeping some other elements like rugby, cricket, badminton, football, baseball, and your intention would be just to match between these, right? So to find the location where it is matching, you can say sports % in %, and then the popular sports, both of them are different vectors, right? And you're just trying to check which one is common, right? So if football is matching with football, that's what you're trying to do, right? So football with rugby, cricket with cricket, basketball with badminton, that's what you're trying to do. So when you do this and you wrap that with the which function, it is going to say that 1, 2, 3, 4 is matching,